everyone. Happy Sunday. I hope you guys are doing well. I know I haven't posted in a while, but my plan is to post more often, and I will be posting more videos in the coming week. So if you have a problem that you want me to solve, or if you have a problem you have difficulty understanding, please drop a comment below and I'll make sure I include them in my next video. For today, we are solving course schedule. This is a really popular problem and almost asked everywhere. It's related to graph. So if you have never solved a graph problem, or if you get intimidated by graph problem, that's totally okay. Graph problems can be daunting in the beginning, but once you have enough practice and once you get the hang of it, I think they're not that difficult to understand. So if you've never seen this problem before, let me give you a quick rundown. So you have been given an order of courses where course A is dependent on course B. So for example, if you take this input, in order to finish course 0, you have to take course 1. So the second element of this tuple is, so you can imagine as an outgoing edge going from 1 to 0. So this, you have to take the second course in the tuple to finish the first course. So for example, if you have something like, let's say 2 comma 3, so you have to take course 3 and then you can finish course 2, right? So that's the idea. Now, if you've never heard of topological sort, I highly encourage you to go through Wikipedia. I do have it open here. But before jumping into that, let's talk about graphs and how we represent graphs in general. So if you've done graph problems before, you know that there are two ways to represent graph. So one is through adjacency list and another is through the matrix. So a list, creating an adjacency list is fairly more common, and I think that's more convenient. So what you do is basically you create a map where your map would have something like integer, list of integer. So the key would be the node itself, and then you can have all the outgoing nodes in this list, right? So if I have something like, so imagine a graph where I have a node 2 and outgoing edges are 1 and 3, I would have something like this. So yeah, that's about adjacency list. So whenever you see a graph problem, the first thing you want to do is transform that into a usable format. So what you've been given is a list of edges, and this is how the input would be given most of the time. It's very rare that you would be given a map. So first thing you need to do is create a format which you can then use. So either create a adjacency list or create a matrix. Excuse me. So I'm going to go ahead and create an adjacency list. But before I jump into coding, I really want to explain the ethos of the problem and the general idea on how we're going to proceed. My goal of making these videos is very simple. I don't want to show off as somebody who is smart enough or who is able to solve a problem. The idea is that we want to make things simple. So things which can be said in one line, we don't want to write an essay on that. And that's what I see in most of the solutions in Leetcode. So if you are somebody who do not understand the solutions, the official solutions in Leetcode, you're not alone, trust me. So what I usually do is I go to Discuss. And in Discuss, you want to go to most votes. Don't go here. So go to the last tab, most votes. And this is where you will find the best solutions. And you can pick a language you want. But yeah, typically, this is where I find the most intuitive and most simple solutions. All right. So coming back to this problem, the first thing we want to do is to make sure we create a usable graph structure. And once we have that, let's look at what is topological sort. So imagine you have a graph like this. And what topological sort is saying is there should be an order, or there should be more than one ordering where you can traverse all this um, given there is a dependency. So for example, there's an outgoing edge from 5 to 11. What that signifies is you have to take the course 5 before finishing the course 11. So if you have an edge 7 to 11, that signifies that you have to take the course 7 before taking the course 11. So what topological sort or Kahn's algorithm states is, let's start with nodes that have no incoming edges. So for example, in this case, 5, 7, and 3 has no incoming edges. So let's start with them and let's add it to a set or a queue, whatever. So we have created a collection of nodes with no incoming edges. Now let's iterate them through that list one by one. So for example, I take 5 and I will navigate through all the outgoing edges from 5. So in this case, I only have one edge. So I will go to the outgoing edge and reach the node 11. And I will remove this edge because I've already traversed through it. And now I'm going to look, okay, if I finish 5, can I finish 11? And the answer is no, because you still have an incoming edge. So you still need to finish 7 before you can finish 11. So that's the whole idea of incoming edge. Like most people do not get it intuitively why we are checking for incoming edge. It's just an ordering that, okay, if you don't have an incoming edge, that means you have already completed the prerequisite course, right? So in this case, I cannot add 11 to my set or my list or whatever data structure I'm choosing. Now let's move forward with 7. Now 7 has 2 outgoing nodes, so you can visit them in any order. It does not matter. So let's say you're visiting 11. Now you have removed this edge and you have removed this edge. So now 11 has no incoming edge anymore, and 11 is eligible to be added to that list. So you already had 5, 7, 3, and now you've added 11 to that list. Now, continuing with the outgoing edges of 7, you are visiting 8, and 8 also has an incoming edge, so you cannot add 8 to the list yet. So you will go to 3 and then follow the same process again. And as you can see, you can have different topological ordering, more than one ordering are possible. All right, so I think this makes sense. If this does not make sense, try to use a pen and paper and understand this, and I'm sure you will understand it. Okay, so coming back to this problem, the first thing we realized is one more thing. Let me show you this solution. So here they are. Where is that? Yeah, this is their solution for topological sort. And as you can see, you don't need to create a class. You don't need to do all this. So I think we can simplify this. But the idea I'm trying to convey is the solution that you see here on Leetcode is not the optimal solution most of the time. So if you do want to see the optimal solution, go to discuss. All right, so now let's start coding. The first thing you want to do is we want to create a graph. And as I said, integer list of integer, that would create our adjacency list. And then we want to navigate through this input that we got. Let me shorten the name, this is too big. And remember, the first input or the first element of the array is dependent on the 0th element. So the key would be the first element of the array, and the value would be the 0th element. Okay, if it makes more sense, we can do this. So this is A, this is B. You don't need to do this. You can directly access the array, but this makes things simple. So the key is the first element, which is B. The first thing we want to check is, let's do this, create a list. So if there's a list already, we can just get it. If there's not a list, we can create a new list. And then we can add it in the map. And then in the end, we get this list and add the outgoing node, which is A, right? So all this is doing is creating a key value structure where your key is the node and the values is a list of outgoing edges like this, right? So in this case, you have a node 1 which has outgoing nodes 2 and 4. Cool. Now, moving forward, we also need some way to know the number of incoming edges, right? And since we already know that the way these nodes are numbered, they are numbered from 0 to n, and n has been given to us, we could really use an array and where its position would be the actual number of incoming nodes. So for example, I can create a, let me show you this. So if you create an in degree so what this is doing is basically it's an array with saying in degree 0, so whatever is the value of in degree of the 0th node, that signifies the number of incoming edges for node 0, for node 1, node 2, and so on. And while we are populating our map, it will be a good idea to add the incoming edges here, because you already know that there is an edge from B to A. So whatever the value of A is, that node has an incoming edge, right? Because remember, the edge is from B to A. So let's do that. Okay, now the next step is to start with nodes. Before we do that, let's decide on a data structure. So you can either take a set or you can take a queue to begin with. And I don't think it really matters what data structure you're using here, because all you're doing is iterating through all those nodes one by one. But what you want to add in that list is number of nodes which has an in degree as 0. So you want to start with nodes like 5, 7, and 3, and these nodes have an in degree 0. So we can check that, and the way we would check that is you already have this list. Okay. So let me do this. In degree dot length. Okay, so now my queue is populated, and the way we are getting the result is in the end, if there are no edges left, so I'm able to successfully remove all the edges, that means that a topological sorting is possible, right? And one way to figure out if my graph has any edges left or not is you count the number of edges you have removed. So every time you're navigating, you're removing edges. So if you just keep a count of how many edges you have removed, and then you can compare it with number of nodes. And if those, sorry, not number of nodes, but number of edge pairs, right? Because um, this num is nothing but number of edge pairs that you have been given. So if you have removed every edge in that edge pair, um, then that means your graph has no edge anymore, right? And a topological sort is possible. All right, cool. So I'm gonna iterate over the queue. And it is also possible that you have a node which is disjoint, like there are no incoming edges. So you still need to count those as well. Okay. And now we need to see if there's any outgoing edge for this node. So maybe I can so here what I'm doing is I'm removing the first element from the queue and then checking if that node has an outgoing edge, because you can have a node which is like a disjoint node which does not have an incoming edge but also does not have an outgoing edge, right? So you want to make sure that you're checking that. Now let's say you have a node where you have an outgoing edge, so you iterate through all the possible outgoing nodes and you decrease their in degree count. And if the in degree count is less than, or I mean you can just do equal to 0, I guess, then that means they no longer have an incoming edge, and you can add it to the queue. That looks right. And then I think that should be it. And then in the end, you have to check if the count is equal to the number of edge pairs. So remember, this num is not the number of nodes, it's the number of edge pairs, right? So what you're checking is, did you remove the total number of edges that those are given in the problem? Okay, let's try this. Cannot find symbol. Okay. Should be. What's wrong with this? Okay, this looks good. All right. Okay, thank you so much for watching. As I said, if you do have any problem that you want me to solve, please leave a comment below and consider subscribing and liking this video. Thank you.